All right, guys, so we're continuing with chapter 6, so 6.3 today. And what we're looking at first is centroid theorem. The centroid of a triangle is 2/3 of the distance from the vertex to the midpoint of the opposite side. So what it's saying is if we look at these lines here, so point P is the centroid. Right here, this is the centroid. And the whole line, so BF is equal to, or well, ABP, this here, is equal to 2/3 of the whole. AP is equal to 2/3 of the whole. So the bigger line is equal to 2/3 of the whole thing. So if we know what the whole length is, well, we can multiply it by 2/3 to get the bigger side. And that's all this is saying. So AP is equal to 2/3 of the whole line, which is AE. BP is equal to 2/3 of BF, the whole line. And CP, the bigger part of this line, is equal to 2/3 of the whole line. Now what this also means is that the smaller section is 1/3. So what we could say is this here, that PE, the smaller section, is equal to 1/3 of the whole. PF, the smaller section, is 1/3 of the whole. And PD is equal to 1/3 of CD, the whole. And we get this here. So either AP, so the bigger portion of the whole line, is equal to 2/3 of the whole, or PE, the smaller section, is equal to 1/3 of the whole line. Now we do have some other properties dealing with the two segments themselves. So AP, the bigger, is equal to twice the smaller. So the smaller section, if we multiply it by 2, we get the bigger. And if we take the bigger section and multiply it by 1/2 or divide it by 2, we will get the smaller. And we have these here. So it might be helpful to pause this here and write these down so that you have them to look back at. Now really all of this is saying is that the bigger length is equal to 2/3 of the whole. The smaller length is equal to 1/3 of the whole length. And the bigger is equal to twice the smaller. And the smaller is equal to half of the bigger. And this is just how it works. This is just the properties of this centroid. And again, the centroid is the line that connects the midpoint of one side to the angle opposite. And we have these here. Now let's look at an example of this here. So we have this here. Now it just wants us to find QW and SW, so the bigger and the smaller, but we're going to find all of them. Now SQ is 8. SQ is the bigger length, and QW is the smaller. And as we just said, the smaller is equal to half of the bigger. So QW is equal to half of the bigger length. Well, half of 8 would be 4. And that's it. So this length here would be 4 because it's half the bigger. Now, SW is the whole length. Well, since I know the bigger and smaller, I know these two parts. The whole length, SW, would be 8 and 4, which would be 12. That's it. Now let's look at the other ones because we have all of them here, so let's go on and find them. Now RQ is the bigger length. The bigger length is always going to go from the angle to the centroid, and the smaller is always going to go from the centroid to the side. So they gave us the bigger length, which was 10. The smaller length is always going to be half the bigger, So we have to divide it by 2, and 10 divided by 2 would be 5. So it tells us that QV is equal to 5. Now RV is going to be the whole length, and well, we can just add those two together, and 10 plus 5 gives us 15. And that's it. Now the last side, our UT, well, they gave us QT, and QT is the bigger because it's going from the centroid to the angle, and that is 12. So the smaller section of that line will be half the bigger. Well, half of 12 is 6. So what that tells us is that QU is equal to 6. Well, if I want to know UT, the whole line, well, I would just add those two together, and 6 plus 12 is 18. And that's all we have to do for this here. That's it. We're done. Okay, let's look at another one. So they want us to find RQ and RV. So we'll start off with that one there. Now what I'm looking at and what they've told me is the distance from Q to V. They told me the distance from Q to V, from the centroid to the side. And that is the smaller length. Well, the bigger is equal to twice the smaller. We double it to get the bigger. Well, 5 doubled, or 5 times 2, would give me 10. So the first part that it wanted was RQ. Well, RQ is equal to 10. And that's it. That's all we have to do. Now, if I want to know RV, the whole length, well, I can add those two together, and 10 plus 5 is 15. And we're done with that part. Now, let's look at the other ones. Now, this one here, they gave me QW. They told me QW from Q to W is 2, and that's the smaller length. And the reason I know it's the smaller length is because it goes from the middle, the centroid, to the side. And the centroid to the side is the smaller length. Now the bigger length, Q to S, is twice the smaller. So 2 times 2 would give me 4. So the bigger length for this one here, SQ or QS, is equal to 4. Now the whole length, WS, well, we can add those two together, and 4 plus 2 gives me 6. And that's it. That's all we have to do for this here. Now that brings us to the last one. They gave us the length from Q to T. And Q to T is the bigger length because it goes from the centroid to the angle. So it's the bigger length. And the smaller length is half the bigger. So we would take 10 and divide it by 2, which would give us 5. So QU will equal 5. Because it's half the bigger, and the bigger length was 10. Now to find the whole length, well, we can just add those two together, and 10 plus 5 would give us 15. And that's all we need to do for this here. And it's really just manipulating these statements because what is given and figuring out what we need to find. So let's look at this one here. If BD and CF are medians, okay, so we're talking about medians, so point E is a centroid of ABC, and CE is 17. 17. What is EF? Well, EF, going from the centroid to the side, is the smaller of the line, the smaller part of the line, and is equal to half of the bigger, or 1/3 of the whole. And CE is what they told me. Well, CE is the bigger portion. So if I want to find EF, the smaller section, well, I need to divide the bigger section by 2. Because EF, the smaller section, is equal to half of the bigger section. Well, 17 divided by 2 will give us 8.5. We just have to cut it in half. And so that's the length that they wanted. Now we could find the whole length also, FC. Because FC will be the bigger plus the smaller, the two added together. And if we add those two together, we would get 25.5. And that's it. That's all we have to do for this here. Okay, let's look at this next one. In RST, RP, and SQ are medians, so that means point U is a centroid. Find RU, the bigger length, if UP, the smaller length, is 7.3. If the smaller length is 7.3. Well, RU is equal to twice the smaller, and the smaller is 7.3. Because they gave us the smaller length, so all I need to do to find the bigger length is to multiply it by 2. And if we multiply 7.3 by 2, we get 14.6. And that's it. Now, if we wanted to find the whole length, PR, all we need to do is add these two lengths together. So we would add 14.6 and 7.3 to get 21.9. And that's it. That's all we need to do for this here. Okay, so this is the next one we're going to look at. So it's going to be very similar to the one we just did. Now, in triangle RST, PR and SQ are medians. So again, U is our centroid. Find RU if PR is 18. Okay, so this changed a little bit because now it's telling me that PR, this entire length here, is 18. Is 18. So it told me the whole length, and we want to find the bigger length. So let's look back here. Well, the bigger length is equal to 2/3 of the whole. So we're going to take the whole length and multiply it by 2/3 to get the big. So when we look at this here, so again, the bigger length, so RU equals 2/3 of the whole. Now, what is the whole? The whole is 18. The whole line is 18 units. So if I want to find out what RU is, I need to multiply the entire line, 18, by 2/3. And if I multiply it by 2/3, I will get the bigger segment. And if we multiply 18 by 2/3, we can do this in a calculator, we would get 12. So the bigger section for this here would be 12. RU would be 12. Now say we wanted to find UP from here. It doesn't ask for it, but we're going to go on and find it. Well, UP is equal to what? Half of the bigger. Well, since I've already found out what the bigger segment is, I found out it's 12. Well, I need to multiply it by 1/2 or divide 12 by 2. And 12 divided by 2 would be 6. And that's it. That's all we have to do for this here. All right, now we're going to look at this one here. Well, okay. Tweaked it just a little bit. SQ is 21, and we want to find UQ. We want to find the smaller. So on this one here, they told us the distance from S to Q, the whole length is 21 units. We want to find out what the length of this is, the smaller. Now, according to kind of our formulas and theorems that we found, the smaller length is equal to 1/3 of the whole. So if I want to figure out what the smaller length is, I multiply the whole length by 1. So to find our smaller length here, we're going to take UQ and multiply it by 1/3, or we're just going to divide it by 3. We're going to divide the whole length by 3 to figure out what this smaller length is. So if I do 1/3 times 21, or 21 divided by 3, I would get 7. So if I'm given the whole length, I'm going to either multiply it by 1/3 or 2/3, depending on what I need or what I'm trying to find. So What we need to do next, and I'm going to go on and do it next, is I want to find the whole length, SU. So to find SU, well, it's the bigger length of this line, so it's going to be twice the smaller. So if the smaller length is 7, if I multiply it by 2 or I double it, well, 7 times 2 would be 14. And that's it. That's all we would need to do for this here. Now we're going to look at a few more problems, these here. Now in this triangle, GP, FM, and EN are medians. So if they're medians, they meet at the middle of each line. So it cuts each line of these in half. It's at the middle, the exact middle. So we know each one of these line segments are going to be congruent. If EM is equal to 2x plus 3, and MG is equal to x plus 5, what is the value of x? Well, because this here, point M, is the middle of the line, it means that these two here are going to be equal to each other. They're going to be equal to each other. So we can set them equal to each other. Because of our theorem, we know that EM is equal to MG. That's just one of the theorems that we do know for sure. So what that tells us is not only that, we know that 2x plus 3 is equal to x plus 5. These are going to be equal because of the fact that it is a median. Now we just need to solve for the value of x. So the first thing we can do is we can subtract x from both sides. And if I subtract x from both sides, I'm left with x plus 3 is equal to 5. Now again, solving for the value of x, the next thing we would do is, well, we would subtract 3 from both sides. And when I subtract 3 from both sides, I get x is equal to 2. Well, now we're done. It just asked for the value of x. It didn't ask for a length. So we're done. That's it. And I knew to set them equal to each other because point M is one of the medians. MF is a median, and it connects to the middle of that line. So EM and MG would be congruent. They would be equal. That's it. Now this one here we'll have to do a little bit more, because here it says that, so we have our medians. So again, these two are congruent, these two, and these two here are going to be congruent because they're all medians. So WS and RW would be congruent. Well, it only gave me WS. RV and VT, so these two here would be congruent to each other. So that's helpful. But let's see what it's asking. What is the measure of RW? So what's this measure if we're given these three values? Well, I can use these two because I know that these two here are congruent to find the value of x. Now, once I find the value of x, we can plug it back in here to get SW's length. And if I know SW's length, I will also know RW. So for us to start, we're going to start out with 4x plus 3 is equal to 2x plus 9. This is where we're going to start, because I need to find the value of x first. And once I find the value of x, I can plug it back in to WS to find WR. So the first thing we need to do is we need to get x on the same side. So I'm going to subtract 2x from both sides. And when I subtract 2x from both sides, I'm left with 2x plus 3 is equal to 9. And again, we're still solving for x, so I'm going to subtract 3 to get x by itself. And if we subtract 3 from both sides, I'm left with 2x is equal to 6. So we're almost done. I just need to finish up getting x by itself, so I'm going to divide both sides by 2. And if I divide both sides by 2, I get x is equal to 3. X is equal to 3. So we found the value of x, which was what we wanted to do at first. Now our next part is we want to plug it back in. We want to plug it back into our 5x minus 1. Because if I plug it back in here, I will find the length of WR. So we're going to have 5 times 3 minus 1. Well, 5 times 3 is 15. And 15 minus 1 gives us not 12, but 14. So the length of WR would be 14 because I solved for the value of x. I plugged it back in for SW and got my length. And that's it. That's all we have to do for this here. Now the other thing we're going to talk about is something called an altitude of a triangle, using altitudes of a triangle. The altitude of a triangle is the perpendicular segment from a vertex to the opposite side, or the line that contains the opposite side. So like with an obtuse triangle, this altitude would not be a part of the opposite side. So we have to have this side containing it. Now the real key thing with the altitude, it's also the height of the triangle. Now the three heights of the triangle, or the three altitudes, will all meet at the orthocenter. The orthocenter of a triangle is where the three altitudes will meet. Now the orthocenter can meet inside of the triangle, like this one here. This one here, they all meet inside of the triangle. This one here, the orthocenter is on the triangle, and that's only if it's a right triangle. Or it can meet outside of the triangle if it is an obtuse triangle. And that's kind of what orthocenter is, and we're not going to do much more with it than that. And that's all we're going to cover today.